In this video, we're going to be analyzing a set of data and a graph in order to make a mathematical model where we can make predictions and solve for specific numerical values. So what I'm looking at is a graph that represents height versus feet, height versus time. And the time is the independent variable, and the height is the dependent variable. Based on where they're positioned in the title, which means that the time is controlled and increased, and then the height is measured as the time is increasing. So say, for example, we are waiting for a certain amount of years and then measuring the amount of feet or height a tree has grown to. Now we have some values that are plotted on the graph. These look fairly linear. If you don't have values that are very linear, or they're sort of more specific or random numbers, you're definitely going to want to use something like graphical analysis or something like Google Sheets in order to get a best fit line. So for what we're looking at right now, this is very linear. We're starting from a value of 2 and then going up to a value of 14. Now what you want to do is you first want to start out with the format y equals mx plus b, the formula for a line. And you want to take those general variables and replace them with specific variables. So our y variable is height. The m is our slope. We'll go ahead and find slope in a minute here. X variable is time. And then our b is our y-intercept. Our y-intercept is where x equals 0 and where our data hits the y-axis. So we have 2, and we want to make sure we grab the units from the y-axis. All of those are heights in feet. So we're going to go ahead and put 2 feet to make sure we have a number and a unit for our y-intercept. Now looking at the data here, we're going to go ahead and use the first and last point to find our slope. So we're basically going to do a y2 minus y1 over x2 minus x1 to find our slope. So our initial value over here is at a coordinate of 0, 2, and this one over here is at a coordinate of 6 and 14. So this is going to be considered our first x value and our first y value, and this is our second x value and our second y value. So let's go ahead and plug those in. We have a y2, which is 14, and we have a y1, which is 2 on the bottom. Our x2 is 6, and then our x1 is 0. So 14 minus 2 is 12, and 6 minus 0 is 6. Okay, along with that, I want to go ahead and include those units. These were the y values, and the y values are heights in feet. So this is referring to 12 feet. And then along the x-axis, we have the time in years. So when we did 6 minus 0, we got 6 years. So our final answer is 12 divided by 6, which is 2. So it's 2 feet per year. So the units are going to be huge in being included with the slope, and it's also going to help you with the meaning as well. So 2 feet per year means that the tree is going to grow an additional 2 feet per year. Now we can go ahead and slide that in. And now we have all 4 components. We have the y variable, we have the slope, we have the x variable, and then we have the y-intercept. Now we have our mathematical model completed. Now we can use it to make predictions. So we have a problem over here, or 2 problems actually, where we're going to find a height where the time is 10 years, and we have a height where the time is 1.5 years. So basically what you're going to do is this. Now, this only goes to 6 years, so we're extrapolating, we're going off the graph. Now, could you see the trend and maybe guess because it's fairly linear? Yes, but one of the best things to do would be to use your actual formula. So we have the height equal to 2 feet per year. Our time is 10 years, plus that starting height of the tree when it was probably first planted. 2 times 10 is 20. plus 2 is going to give us our answer. So that means our height is 22 feet. Now for our second problem, we are going to be looking at a time of 1.5 years. So this goes from 0 to 2, 1.5. Can you look at the graph and interpolate and find a point on your line and have a pretty good estimation of what that number is? Yes. But you're going to want to plug it into a mathematical model if you can, because it's going to give you a very exact number without eyeballing anything on a graph. So we have h equals 2 feet per year, and that's times 1.5 years this time, plus 2 feet. So 2 times 1.5 is 3, and then plus that 2 is 5. So our height is going to be 5 feet. So to sum things up, when you are creating a mathematical model, you're going to use the y equals mx plus b format, but you're going to find the very specific y variable, slope x variable, and y-intercept from your set of data or your graph. And then once you plug in all of those very specific things, make sure you include units with each of your numerical values with your slope and y-intercept. And now you have a formula that can give you very specific values. So once you plug those things in, if you have a specific x value such as this, we had 10 years, then you can go ahead and then solve for your y variable. Okay, or the other way around, you might have been given a height. You might be given a height of 22 feet, and then you can go ahead and work out the algebra and then solve for your x value as well. Okay, either way, your mathematical model is a great predictor of giving you a very specific numerical value within your graph and outside of your graph. So I hope that was helpful to you. Thank you for watching and listening.